today what we are going to do is, we are going to start with the next part. Now we are reaching the last part of the topic. We will be discussing this, something called as reference electrode. And one important example of reference electrode is SHE. SHE, standard hydrogen electrode. Important question. First point, let me clear. What is reference electrode? A galvanic cell consists of two half cells, one half cell, one electrode where oxidation takes place, which acts as anode, negative, and the other half cell, reduction takes place, positive, cathode. Students, if the potential of cell potential of one of the electrodes is completely taken as 0, then whatever is the total potential of the galvanic cell, that is whatever is the total potential of the galvanic cell, that is the potential of the other electrode. One such standard electrode which is used as a for reference. Why we do that? I'll give you what are the uses of this. Let me repeat what I said. Galvanic cell consists of two electrodes. If in that process the potential of, because whatever potential difference is obtained across a galvanic cell, and that is due to the combination of both the potentials at the anode and cathode, what I will do is, let me reduce the potential of one of the electrodes, maybe cathode, maybe anode, as 0. Then that particular electrode, I will repeat, that particular electrode whose potential is reduced to 0 is called as reference electrode. Okay, means what is the reference electrode among the cathode and the anode? If one electrode's potential is reduced to 0, then that electrode is called as a reference electrode. For practical purposes, the most commonly used electrode is the standard hydrogen electrode. Why so? Which is obtained as follows. Students, standard hydrogen electrode हे सुरुवातीला वापरायचे. आता त्याला ऑप्शन्स म्हणून भरपूर इलेक्ट्रोड्स आले, लाइक कॅलोमिल इलेक्ट्रोड इज देयर, सिल्वर क्लोराइड electrode is there, and all that, which are much better than standard hydrogen electrode. So let me tell you, standard hydrogen electrode is the one whose potential is arbitrarily taken as 0. See here, the standard hydrogen electrode diagram सकट, answer सकट, reaction सकट, सगळे important आहे, नोट करा मुलांनो. What is the standard hydrogen electrode? SHE म्हणतात त्याला, standard hydrogen electrode. The diagram goes like this. There is a platinum plate coated with platinum black. It is made to pass through a U-tube. It is made to pass through a U-tube. The platinum plate is connected to a copper wire for external connection. हे जरा रब करते हैं, copper wire for external connection. तो ही the platinum plate is coated with platinum black. This is your platinum plate, which acts as electrode. Okay, it is connected to a copper wire made to pass through this mercury is there. Why? Because when it is passed through mercury ensures proper contact म्हणून mercury वापरतो. Made to pass through a U-shaped tube. Then the U-shaped tube is surrounded by a jacket. Through which hydrogen gas is bubbled. hydrogen gas is bubbled. Okay, fine. Next, the jacket is dipped in a container. The jacket is dipped in a container. This assembly is called as SHE, standard hydrogen electrode. Look here. Platinum plate coated with platinum black. A wire is attached, made to pass through a U-shaped tube. The U-shaped tube is surrounded by a jacket through which hydrogen gas is bubbled. Okay. Then this jacket along with the platinum tube is placed in a container containing 1 molar hydrogen ion concentration. Containing what? 1 molar hydrogen ion concentration. Let me repeat. The platinum plate behaves as a electrode. Students, it is an inert electrode, meaning it does not participate in the chemical reaction. Means it acts as an inert electrode. It does not undergo redox reactions. त्याच्याकडे धड ऑक्सिडेशन मध्ये ते स्वतः पार्टिसिपेट करत नाही इन द रेडॉक्स रिएक्शन्स. प्लॅटिनम प्लेट बिहेव्स एज अन इनर्ट इलेक्ट्रोड विथ नॉट पार्टिसिपेटिंग इन द रेडॉक्स रिएक्शन. मग होतं काय स्टुडंट्स, मग याचा यूज काय, मग ही प्लॅटिनम प्लेट वापरायची कशाला, तर प्लॅटिनम प्लेट हेल्प्स इन द conversion of gaseous hydrogen into hydrogen ions. So platinum plate behaves as an inert electrode, means it does not participate in the redox reaction, but it helps in the conversion of gaseous hydrogen into ionic form. हे बघा, H2 gas takes up electrons, or we'll put it like this. The hydrogen ion reduction reaction घडतं at the electrode. Reduction reaction where the hydrogen ions take up the electrons to form hydrogen gas. The standard potential of the cell is 0.00 volt. That's it. The hydrogen ions reduction reaction होता where the hydrogen ions, 1 molar hydrogen ion is undergoes reduction to liberate hydrogen gas. So hence the solution is surrounded continuously. तुम्ही hydrogen gas जो form होता त्याचं water होतं मुलांनो in the near future. That is the thing here. What is the use? हा standard hydrogen electrode चा use काय? You know, arbitrarily त्याचं potential 0 धरलं जातं. And in a galvanic cell, if it acts as an anode or a cathode, मुलांनो, we can measure the potential of the other electrode accurately. हाँ, समजा सर cathode बरोबर हा anode म्हणून वापरला, then we can measure the potential of the other partner. हा ह्याचं potential 0 धरायचं, दुसऱ्याचं potential positive धरायचं. For example, आता समजा if this is acting as a cathode where reduction is taking place, now I will take zinc. We'll take zinc ions. हे बघा, हे what you can say, chemical formulation. Zinc ion will take zinc as an electrode dipped in 1 molar zinc ion. सॉल्ट ब्रिजची गरज पडत नाही. प्लॅटिनम घेतला आणि हायड्रोजन as the electrode whose reference is taken as 0. Directly you can measure the potential of this anode because it's written on the left hand side, and cathode hydrogen gas because reduction takes place, and that's it. Are you okay here? Point number 1. हे झालं रेफरन्स इलेक्ट्रोड. म्हणजे गॅल्व्हॅनिक सेल मध्ये एक कॅथोड म्हणून वापरायचा, एक हाफ सेल कॅथोड म्हणून वापरायचा, आणि दुसरा आपण स्टँडर्ड हायड्रोजन इलेक्ट्रोड म्हणून वापरू शकतो मुलांना. ज्याचं पोटेन्शियल 0 धरल्यामुळे त्या जे काय कॅथोड जे काय ॲनोड आहे त्याचं पोटेन्शियल ॲक्युरेटली मेजर करता येतं आपल्याला. दॅट इज द थिंग हियर. स्टुडंट्स, हेच त्याचं मेन यूज आहे, दॅट इट इज टेकन ॲज अ रेफरन्स इलेक्ट्रोड टू मेजर द पोटेन्शियल ऑफ द अदर इलेक्ट्रोड. लाईक फॉर एक्झाम्पल झिंक तुम्ही ॲनोड म्हणून वापरला तर झिंक इलेक्ट्रोड डिप्ड इन झिंक आयॉन्स. प्लॅटिनम इनर्ट इलेक्ट्रोड म्हणून वापरला जातो, ज्याचं फक्त आयोनिक फॉर्म गॅशियस ते आयोनिक फॉर्म मध्ये कन्वर्शन. अँड देन यू हॅव द हायड्रोजन गॅस which acts as the hydrogen gas which acts as the cathode. That's it. हे एक झालं. असे भरपूर एक्झाम्पल्स आपण घेऊ शकतो. नाउ व्हॉट आर द ड्रॉबॅक्स, म्हणजे रेफरन्स इलेक्ट्रोड म्हणून SHE का नाही वापरला जात. देयर आर सम ड्रॉबॅक्स म्हणून. फर्स्ट ऑफ ऑल, इट इज व्हेरी डिफिकल्ट टू ऑब्टेन प्युअर अँड ड्राय हायड्रोजन गॅस, कारण ते हायड्रोजन गॅस मॅन्युफॅक्चरिंग इज व्हेरी कॉस्टली. सो इट इज डिफिकल्ट टू ऑब्टेन प्युअर अँड ड्राय हायड्रोजन गॅस. फर्स्ट. सेकंड, इट इज डिफिकल्ट टू मेंटेन द प्रेशर, कारण आपण जो हायड्रोजन गॅस इथं बबलिंग घेतो ना, इट इज ॲट 1 atmospheric प्रेशर. So it is difficult to maintain the pressure of hydrogen gas as 1 atm, 1 atmosphere. Third, it is difficult to maintain the concentration of hydrogen ions as 1 molar. Why? Because continuously water form होतोय आणि water form होऊन ते evaporate होतंय मुलांना, आणि त्यामुळे to maintain the concentration of hydrogen ion as 1 molar, it becomes more and more difficult. I'll repeat. What are the limitations of this reference electrode, that is SHE? First of all, it is difficult to obtain, it's very costly. It's difficult to obtain pure and dry hydrogen gas. It is difficult to maintain the pressure of hydrogen gas as 1 atmosphere. Third, जे तुम्ही हायड्रोजन गॅस बबल करता तो. And third is that it is difficult to maintain the concentration of hydrogen ion solution as 1 molar. Reason? Because continuously water is formed which undergoes evaporation. त्यामुळे त्याचं कॉन्सन्ट्रेशन 1 मोलार ठेवणं कठीण जातं. That's it. Next, galvanic cell type घेऊया. Galvanic cell can be categorized into 2 types of cell. Galvanic cells are also called as voltaic cell. Galvanic cells or voltaic cells can be classified as primary voltaic cell and secondary voltaic cell. Now what is primary voltaic cell? Students, in this particular galvanic cell, the chemical reaction begins. Electricity is obtained. Galvanic cellचा principle तो आहे that chemical reactions produce electrical energy. But in this simple voltaic cell, once the chemicals are completely used up, म्हणजे आता समजा तुम्ही कुठलंही एखादं झिंक क्लोराइड किंवा असं वापरलं, once the chemical is completely used up, students, तर करंट प्रोड्यूस होणं स्टॉप होऊन जातं. And under any conditions you cannot get back those chemicals. That is one category of galvanic cell which is called as simple voltaic cell. There are other category of galvanic cell where we call the secondary voltaic cell. हे primary voltaic cell किंवा simple voltaic cell म्हणतात. There is one more category of galvanic cell which is called as secondary voltaic cell. Secondary voltaic cell मध्ये काय? Same. Chemicals are used up to produce electrical energy, but the reaction can be reversed. How? External potential घ्यायचं. आता हे कसं तुम्ही एक्सटर्नल पोटेन्शियल जोडलंय, एक्सटर्नल पोटेन्शियल घ्यायचं मुलांनो. ते एक्सटर्नल पोटेन्शियल जर जरा हाय केलं तर द सेल रिॲक्शन अंडरगोज becomes reverse, or it forms it acts as a reversible process, and under this conditions we get back the chemicals. म्हणजे थोडक्यात काय, chemicals are used up to produce electrical energy. By applying a potential of with the help of an external source a little bit higher, we can reverse the reaction and get back the chemicals. That is the main use of secondary voltaic cell. And one such secondary voltaic cell is the dry cell or the Leclanché cell. Okay. Now what is the dry cell or Leclanché cell? Just follow here. Very easy it is, Mono. Leclanché cell or dry cell. What is it? What is the dry cell? It is a secondary voltaic cell. Secondary voltaic cell means where by increasing the potential with the help of an external source, we can reverse the reaction and get back the chemicals. त्याला secondary voltaic cell म्हणतात. Best example is Leclanche cell. Now what is that? Center lamp. You take a graphite rod. Graphite rod. This is a zinc container. Graphite rod acts as anode. Zinc container acts as cathode. This is zinc container. Zinc container is surrounded from within by a porous plate to prevent its contact with the electrolyte. पूर्ण ही जी रिकामी जागा आहे ना, हा स्पेस जो दिसतोय, it is filled with a paste of ammonium chloride and zinc chloride. Okay, it is filled with a paste of ammonium chloride and aluminum chloride. Al2O3, AlCl3. The graphite cathode, the graphite which acts as the anode here. The graphite is surrounded by manganese dioxide and carbon black. Manganese dioxide and carbon black. This is the assembly here. Okay. So what is a dry cell or a Leclanche cell? Center anode graphite rod surrounded by a layer of manganese dioxide and carbon black, that is surrounded by an electrolyte which is a mixture of ammonium chloride and AlCl3, aluminum chloride. All this is enclosed in a zinc container which acts as the cathode. Okay. The cell is sealed from the top to prevent the drying of the paste. That's it. Are you okay here? Now the next part will be the reactions that I will deal in the next class. Okay?